All right.
Good evening.
Good evening, gentlemen. Rick, you there? Hello, Rick.
I'm trying to catch up. Here I am.
Oh, there you are.
There you are. And you're a
Ghost,
little bit
ghostly image.
Yeah, it was a little vignetted. That would be the right word he is.
There you go.
Well, good evening, everyone. Welcome to Virtual Telescope Viewing. You're tuned into the Chabot Space and Science Center Facebook channel or YouTube channel. And I want to remind everybody that we're gearing up to reopen at the Chabot Space and Science Center. So notice I'm not starting off by saying I want to remind everyone that the Chabot Space and Science Center is closed. It's such a downer to say that every week. So
even though it's true.
Even though it's true, I'm going to say instead that we are working on reopening the Chabot Space and Science Center, and we are scheduled to reopen on the 12th of November. And so on the 12th and the 13th, you'll be able to come up here and look through our fantastic telescopes, and including Nellie behind me. And then a week later, on the 19th, East Bay Astronomical Society will be reopening the Telescope Makers Workshop. So we've got all kinds of stuff planned, and we're all excited about this. I want to remind everyone that because we're not open yet, we are still depending on people's donations, and so hit that donation button on your Facebook page and help us out. I also want to thank Fremont Bank for its ongoing sponsorship of this program and others, and that's about it for the commercials. Right? Got anything else?
Yeah. No.
Yeah. All
That's
right.
good. Yeah.
Good.
All right. You should do this professionally.
Yeah, I don't know about that. But I do want to say one other thing. I want to say that the humidity is low and the sky is clear.
And the seeing is good.
And the seeing is good.
That's good. Right. So if you're tuned in tonight, you picked a good night to do so.
So what's up first? I think there's a big planet that we have to look at, right?
Let's see here. I think we've got to go.
So for those of you who've not watched before, if you notice the big telescope behind our shoulders here, that is the telescope we call Nellie. It's a 36-inch reflecting telescope here at the Chabot Space and Science Center. And it has a camera mounted on it right now, and that's what you're looking at. You can see what the camera sees. Are we live view, or is this a still image?
No, we should be live view right now.
This is live view.
I'm going to see if I can't reposition. Oop, I can reposition in the wrong direction.
You can reposition Jupiter right off of the screen.
How's that? Does that help?
Well, the other position, you were able to see the Galilean moon.
Let me do it.
I don't know. You could have paddle fights here.
Yeah, really.
Okay.
Yeah. You must have a very slow shutter speed selected.
It's 1/250th of a second.
Really?
Yeah. There's probably a delay going through Zoom and all that stuff. Yeah, but
there we go.
All right, I see 2 moons, 3 moons.
We had 4 moons visible. The first moon to the left of the planet, and the planet is just almost left the screen. That's Io.
Yeah, I'm not sure what you're doing,
what's happening?
Well,
maybe I should take over. I think I have a control here. Wait a minute.
Actually, somebody's doing something because I'm not even pushing buttons. I'm not even pushing buttons here.
Well, I don't have. My hands are here.
I have the controller, but it's actually sitting. It's all by itself. Hey, well, we are getting close to Halloween. Who knows?
Yeah. Okay.
Oh, Rick, you could take the bullseye off.
All right, I'll take that off.
There we go.
Are we trying to recenter? There we go. Now it's coming. Is it coming back on its own? This is getting too spooky here.
I am pushing the button and nothing's happening.
Okay, stop.
Yeah.
There we go. Perfect.
Okay, what I'm seeing on Zoom is not what you're seeing there.
No?
Well, there's a delay.
No,
Oh,
no.
I'm seeing this.
Okay, I don't know what's going on here. I'm seeing.
Yeah, I see on Richard's screen there. Yeah. We're having technical difficulties. The three computers within 20 feet of each other are not synced up for some reason.
Okay, well, there's Jupiter. And I can see 1, 2, 3 moons to the left of it.
Well, there's actually a fourth one. Let's shorten the exposure. It'll bring up the moons. There we go. See the 4 moons?
Yeah,
well, actually,
yeah.
will in a second. So you've got Io on the left, and then the next one out on the left is Europa. The next one furthest out is Callisto, and then the last moon is Ganymede. Ganymede right out here.
All right.
Okay, why don't you cut that back to maybe 300, and let's see if we can pull out any detail on the planet.
Yeah, I can see some bands earlier, so.
Yeah, let's see. Let's shorten that exposure.
All right,
Say
so we're
keep going until we start seeing dimming. There we go.
All right. So while he's doing that, I'll tell you a little bit about
That's great.
Jupiter. Jupiter is the largest planet in our solar system. Jupiter is 11.2 times the diameter of the Earth. So it's 88,000 miles across, whereas Earth is only about 8,000 miles across. Jupiter is a gas giant, so it does not have a solid surface. Instead, it is basically a big ball of gas with maybe a somewhat solid core deep down inside. It is rotating very rapidly. A day on Jupiter, depending on where you measure it, is roughly 9 hours and 55 minutes long. So Jupiter is turning very rapidly. It does have an atmosphere. There's lots of dense clouds in the atmosphere, and it has high and low pressure areas in the atmosphere. But because it's rotating so rapidly, those highs and lows wrap around the planet rather than looking like little swirls like what we see here on Earth. The highs and lows wrap around the planet, and that's what produces the banding that you see. The dark bands are what we call belts, and the light bands are what we call zones. And the belts roughly correspond to low pressure, and the zones are high pressure. Jupiter is about 5.2 times farther from the sun than the Earth. So it takes a lot longer to orbit around the sun. Jupiter takes just under 12 years to make one complete orbit around the sun. So we say that Jupiter's year is is roughly 12 Earth years long. And then, of course, Jupiter has a lot of moons. I think we're up to over 80 now. But there are 4 moons of Jupiter that are the largest moons. And they're what we call the Galilean moons because they were discovered by Galileo in January of 1610. Those moons are called Io, Europa, Ganymede, and Callisto. And I think they're all lined up on one side of the planet right now.
Yeah, all on the left side of the planet on our view here.
Yeah. So Jupiter.
Great.
Yeah. Now, the upper part, the part that you see, that's basically just cloud. Most of that cloud is hydrogen. There are some other elements and components in it. There's helium, there's methane, carbon dioxide. There's even some water in there, but it's mostly hydrogen. As you go deeper into the atmosphere, you can go a long way because, like I say, there's just a small core at the very center. But between that core and the outer surface, which is what you're seeing, there's just progressively denser and denser atmosphere. And it's mostly hydrogen. And when you get down deep enough, the pressure is high enough to where hydrogen does a really cool thing. Hydrogen we normally think of as a gas, just floating around, random atoms floating randomly. But if you put it under enough pressure, it does a strange thing. The hydrogen atoms all kind of line up, and the electrons floating around the hydrogen nucleus start to be free floating. And as a result, it becomes electrically conductive. It's also kind of shifts from being a gaseous state to being more like a liquid state. So when we reach that phase of hydrogen, which you only get under these conditions of very high pressure, we call it liquid metallic hydrogen. It's metallic because it conducts electricity. So that's a pretty curious thing. And it's something we can duplicate in the laboratory under very difficult conditions, but you got lots of it on Jupiter.
So Renato is asking an interesting question, and he said, or asked, what is the distance between the moon closest to the planet and the one farthest from it? Well, I've got to tell you that that answer changes from minute to minute, right? Because the moons are all in separate orbits. So the rotational speed of Io is very different than the rotational speed of Ganymede and Callisto. So right now, all the moons are on one side of Jupiter. And if I was to assume they're all in a perfectly straight line, then I would guess that they're probably a couple 100,000 miles from one another. Jupiter is 86,000 miles in diameter, and you can kind of eyeball those distances that, Io is about 80,000 miles from Jupiter, and the next moon out is spaced about the same. And you can kind of do an eyeball calculation. But if I come back in a couple of days, you'll see one of the moons out on the other side of Jupiter, or one might be behind it. So those distances are always changing.
One of the other interesting things about their orbits, Io takes roughly 2 days to orbit Jupiter. Europa takes 4 days. And then Ganymede takes, Ganymede takes 8 days. So they're what we call in resonance to each other. All right. So that's Jupiter. So that's our first planet of the night. We got 2 more to show you. So shall we head on over to Saturn?
I think so.
All right. Stand by here.
That's the easiest jump.
And here we go. So the computer or the telescope we're using is computer controlled. So it, I don't see anything happening here.
No, it's happening.
It's happening. I see it. Yeah.
It's just happening very slowly on your screen for some reason. I don't know.
Yeah, that is strange.
It is.
Well, let me just center Saturn here.
Yeah, and we'll let you know when you can sync it up in the computer. Oh, all right. That's good.
Okay, centered.
All right. You can get rid of the bullseye and increase the exposure. Yeah.
Okay.
So for you, it's centered, huh?
Oh, yeah.
Yeah.
For me, too.
Oh, interesting. It's just now got centered on my screen. I don't know what the heck is going on here.
You're on a different Wi-Fi than us.
We're on the good Wi-Fi.
We're on the good
I'm
one.
not on Wi-Fi at all. I'm on Ethernet.
You're on that router. Ah,
Yeah.
that's interesting. All right.
Well, let's see what we can do for exposure.
So this is Saturn.
I would go with a shorter exposure and greater ISO.
Saturn is not quite as big as Jupiter. Saturn's diameter is about 9.5 times the diameter of the Earth. And coincidentally, its distance from the sun is about 9.5 times the Earth's distance from the sun. Saturn's day is a little bit longer than Jupiter. It's about 10 and a half hours long. So it too is spinning pretty fast. And you get the same banding on Saturn, but not as noticeable. The bands on Saturn are not as dark as they are, or the belts on Saturn are not as dark as they are on Jupiter. So in a lot of telescopes, Jupiter looks pretty bland.
Yeah, we're seeing a lot of
turbulence
too, so I think that's really affecting the scene tonight for Saturn.
Yeah.
A much smaller object. I mean, from an angular scale size, it's about 1/4 to 1/3 the angular diameter of Jupiter. So we have a much smaller target to look at. So we've raised we're up at 400% magnification on our image.
I'm gonna let you guys chat for a second. I'm gonna log off and log back on here because I'm just having a lot of problems here. So
yeah, Rick, I'm wondering if you actually reduce the magnification a little bit because it's probably over magnified, and maybe we can also, just in case, test out the focus to make sure we didn't.
Yeah, we need a star or something to test that focus.
We could just do it with the planet and try it.
All right. I'll use the.
Yeah, there you go.
A little better.
Oh, that's much better.
Okay.
Yeah, that made a difference. Now go ahead and bump up the magnification again, real quick.
All right.
Let's go up a little bit more. Yeah, look at that. Now you can see the Cassini division.
Yeah, right there. Oh yeah, that made a big change right there. Well, let's overexpose this a little bit and see if we can see some of the moons.
See some of the moons, yeah.
Yeah.
Gerald, did that help going back in?
I think so.
Yeah. But you can't see moons. We see 3 of them.
Yeah, I got an immediate response that time. So yeah.
Okay. So let's see.
Can you zoom out a little bit, see if we can spot any of the moons at all?
Yeah,
we'll be able to see Titan.
I see 3 right now.
We see 3 of them right there, and
oh yeah, okay.
So
they're not very sharp.
No, they're not.
No. Let's see if we can sharpen them with the focus.
Yeah, not wrong direction.
I'm just tapping the focus. It's going the wrong way.
Yeah. There you go. That's it. That's as good as you're going to get.
Yeah. All right, let's.
So if you hear a lot of music in the background, folks, it's because we have an event going on up here at Chabot. There is a wedding event that is happening outside of the observatories, and they're getting pretty loud and noisy out there. So you just have to grin and bear it.
Yeah, I don't know if it's coming through. I can barely hear it through my headphones here.
Yeah, it's not too bad.
Yeah.
So let's see if we have any questions on YouTube. Nothing on YouTube, actually. A lot of people are actually talking about Mars on YouTube.
Well, wait a
So
minute.
there's a
We're
lengthy
looking at
conversation
Saturn right now.
Well, it's like at least we're
maybe
talking
the-
about planets.
Well,
Give us some of those
watching you guys
telescopes
fiddle,
up.
watching you guys fiddle with the software, like learning how to use it for the first time, and so they say, "Well, let's talk about something else." So,
Yeah.
so anyway, we got Saturn. You see the rings. The rings are mostly ice, ice chunks like about the size of your fist, maybe some of them a little bit bigger, size of a bread box or so. And they're all orbiting in a very thin plane. The most of the rings are less than 100 meters thick. In fact, most of them are less than 50 meters thick. And so they're very thin, and at certain times we can actually see them edge on, in which case they almost seem to disappear because they're so thin. The ring particles orbit around Saturn, but the time it takes them to orbit depends on how far they are from the planet. So the ring particles that are in close to the planet orbit faster than the ring particles that are out near the outer edge of the rings. And because of that, you can't see it here, but you get a lot of individual rings. It looks like one big ring or maybe a few large rings that we see here. But when you get up close, you actually see that there are hundreds and hundreds of very thin or very narrow rings that are all just one right next to the other. And they form the major ring system that we see from here on Earth. That's pretty interesting. We had a spacecraft orbiting around Saturn called Cassini. It went into orbit in 2004 and stayed in orbit until 2015, and just sent back some great images of the rings, close-up images where you can clearly see that the rings are actually hundreds and hundreds of rings, one right next to the other.
Now, the outcome of the Cassini's mission, of course, was sending Cassini into Saturn's atmosphere.
Yeah.
As a final coup de grace.
Yeah, the reason they did that, was to avoid contaminating any of the moons.
Oh, very interesting.
There is a plan, an active plan to send another spacecraft to Saturn, to at least one to go into orbit around Triton, maybe one to look at Enceladus. And what you don't want to do is contaminate those moons by crashing Cassini into it and then discovering, well, actually there was some bacteria, Earth bacteria, still surviving on Cassini, and it crashed into one of those icy moons and liked the weather there, so it started growing. And so then when you send a spacecraft there 20 years later, hey, you've discovered life on Enceladus, only to discover that what you've discovered is life on Earth that got transferred to Enceladus because of a dirty spacecraft. So to avoid that happening, they deliberately crashed Cassini into the planet itself.
I think we owe Renato a clarification on something here. Yeah, you had mentioned, Gerald, that the rings of Saturn will disappear. They're not going to disappear like they're going to be gone. They're just going to be much harder to see because the angle at which they are tilted with respect to our eye here on Earth will be so slight that it will be just a straight line and it won't be reflecting enough light to be dramatically visible.
Yeah,
and then a couple of years later, that tilt will increase enough to be showing us the rings as we normally are used to seeing them.
I've actually got an image that can show.
Oh yeah, let's show that again. That was a great image.
I'm trying to find it right now, so bear with me here.
So while you're looking for that, Larry, you asked, are there planets not orbiting a star, just orbiting around in the Milky Way? The answer is probably yes. because orbits can be destabilized. And if you have planets around a double star, or now we've discovered planets around a triple star, it's very possible that given enough time, a planet can become ejected from its star system. Or if two stars pass close enough to one another, it can cause so much disruption gravitationally that a star gets ejected. That a planet gets ejected. And so the answer is probably yes. Very unpleasant place to be, I would think. There's your image.
Yeah, so this is actually a Hubble Space Telescope image collection. I have one from Damian Peach, but I can't find it. But this one shows the idea. Saturn takes nearly 30 years to orbit around the sun. The ring plane has a certain tilt relative to the orbit around the sun, but that tilt remains the same direction. So as it orbits around the sun, from our perspective, the tilt changes and it goes through a cycle. When it's at its maximum, then it gets a little less and then a little less. And then each year as we go around the sun, it takes 30 years for Saturn to go around the sun. So we take one complete trip around the sun and the tilt is a little less. Another trip around the sun, it's a little less. Another trip around the sun, it's a little less. And eventually we get to the point off the frame down here where the ring plane is edge on. And when it's edge on, because the ring plane is so thin, we literally can't see it from Earth. And that only happens for a short period of time. And then the tilt continues in the other direction. And it eventually goes, if you imagine this tilt going in the opposite direction. And that's, somewhere down here in this string of images. And that takes 15 years to go from maximum tilt in one direction to maximum tilt in the other direction. And it takes 30 years to do one complete cycle. So from maximum tilt here, maximum tilt in the other direction, and then back to here. So that's what we're talking about when the rings disappear, is when we see them edge on. All right, back to you, Rick.
Rick, you ought to pull the share from Gerald.
No, I'm.
Yep, we're there. We're there.
Oh,
we're
yeah,
there.
we go.
Okay.
Yeah, there we go.
Yeah.
All right. So we're still
okay.
there.
Okay. Well, I think we were talking about maybe looking at one other planet.
Yeah.
All right.
Which one? Earth?
Well, we all get to see Earth every day.
That actually would be
Most
more
of
of a
us.
challenge.
Yeah.
That would violate our limits on the telescope. I think we're going to take a look at Neptune, right?
Yeah.
Oh,
right.
nice.
Neptune
nice.
it is.
If I can learn how to spell it.
With an N?
Could not find. Yeah, like I say,
I think you transposed the letter there.
I've got that European spacecraft that just flew by Mercury.
Oh, I brought a photo of that.
Bepi Colombo.
Yeah.
So I spelled Neptune Beptune.
Hey, that was close. Yeah.
So, all right, here we go. Slewing.
Slewing to Beptune.
Neptune. That's why we recommend spell check. Yes, it helps.
All right, are you in live view?
Yes, we are in live view. Are we there?
We'll be shortly.
Well, I think.
Yeah, you may have to change your exposure.
Yeah.
Okay.
There it is.
There it is. And that's with a 2-second exposure.
So this gives you, I just want to point out to people that Neptune is in the same size class as Saturn, and it's a big gas giant, but you're looking at a much smaller dot here, which gives you a sense of how much farther away it is. So it's almost star-like in the same view as we had for Saturn.
Yeah, so I'm going to try and hope that, yeah, hey, there you go.
So the only thing you could really, actually, I see a couple of moons.
Do you?
Yep. But I do want to point
Hey,
out.
Rick,
Yeah.
if you're going to handle the paddle, you got to tell me. Otherwise, we're going to be fighting each other.
I know. I've been watching this from a distance, and
This is like dueling paddles.
once again,
Okay.
I want to mention to everybody that I'm not part of the problem here.
Okay. All right. See, I've got the tool right there.
I have
All
one
right.
too.
That's the problem. Okay. All right. It's like, who's on first, right?
Yeah, right.
Yep. So what is always really nice when observing Neptune is the color. I mean, it's got that kind of that beautiful bluish white color that is really unique.
Yeah, that's actually because it has a little bit more methane in its atmosphere than Jupiter does. So it still has a lot of hydrogen in its atmosphere, but it has a lot of methane, and that gives it that bluish color.
So let's snap a 4-second exposure. Maybe we can bring out some moons.
So here's a question for you, Gerald.
Right.
Why is the methane in Neptune in a gaseous state and not liquid when we're that far out from the sun? Is it because of the amount of friction that's warming it up to the point that it remains in a gaseous state?
Yeah, I believe so, but don't quote me.
All right.
Oh,
that's great, Rick. Look at that.
I'll have to work on coming up with an answer for that question, because that's
All right.
good question, because it is very cold there. So
yeah.
So we have
and it may be that the methane is in the form of droplets rather than gas.
Rather than gas. All right, that's interesting. All right, this is a great image here. So we're seeing two moons of Neptune. Triton is probably the one on the right. I'm going to guess.
Nereid
Yeah,
and Nereid is going to be the one that's closer to the planet. That's great. All right, so you've seen Neptune and two moons, which is actually usually very difficult to see through a, typical amateur telescope.
Well, having a 1-meter telescope does help.
Yes, it does.
Yeah. So Neptune is really far out there. Remember how I said Jupiter was 5.2 times farther from the sun than the Earth, and Saturn was 9.5 times farther from the Earth or from the sun than the Earth. Neptune is 30 times farther than the Earth. So it is way out there. It's pretty cold out there. So it has a very long orbit. I can't remember the amount of time off the top of my head, but we'll look it up here in just a second and let you know for sure. But it's a very long period of time for it to make an orbit.
And actually, I don't think that's Nereid. Nereid is way out on the left. This is Triton right here.
Yeah,
this is Triton.
Yeah, Bob was just pointing that out to us, so I was wrong. I thought I was going by the brightness, and I thought that Triton would be the brighter of the two. And but anyway, Triton is
Triton
is
should
the
be this one right here.
That appears to be closer to the planet, but it's out behind it.
Yeah, that other star is a 13th magnitude star, so it's pretty
so it's
pretty
not part
dim.
of it.
Yeah, no.
Yeah, okay.
It's posing as a
moon.
As a moon.
So Bob is near. Bob is looking at Sky Safari right now. Is Nereid visible, or can you point out the position to us in the chat? So we don't have that.
Yeah, let's actually get a little longer exposure. I'm thinking Nereid is out. It's out on the left, almost at the edge of the frame.
Ah, you think it's that?
Yeah, so I know it is. I'm looking at Sky Safari, and I'm just trying to get the. Okay, 1, 2, 2. No, it may not be on the frame. I don't think that's Nereid.
I'd be really surprised if it was. That seems way too far out.
Yeah, this may be Nereid right here.
Huh.
It's almost in a, yeah, 1, 2.
Well,
Yeah,
I was certainly
hard to
way
say.
off. Yeah.
Yeah.
All right, we had a couple of other questions. Can the moons of Jupiter be seen with the naked eye these days? That's a tough one. You can see them easily with binoculars, but I don't think I've ever seen them naked eye, nor do I know anybody who's claimed to.
You definitely can see them with binoculars, and a small telescope easily shows them up. I mean, Galileo discovered them, and he was using a very small telescope. You have, typical binoculars have more magnification, or almost the same magnification as Galileo's first telescope that he was using.
Do we have any way to show where these are relative to each other in our sky right now? Well, if you're able to find Jupiter, and this is directed at Laura who asked, if you're able to find Jupiter, which it sounds like you are, then Saturn is the bright object to the right of Jupiter, and about a hand's breadth distant when you hold your hand out all the way in front of your face. Neptune, of course, is not visible to the naked eye. That's why it took so long for us to discover Neptune.
And actually, Nereid, I was just checking that it's a 19th magnitude moon, so it would be a really tough object in the city here if we were to see it at all. Yeah.
Got it. Okay. Well, thanks for that. I was overly optimistic.
Yeah. While you guys were talking here, I looked up Neptune's year is 164 Earth years.
Ooh.
So actually 164.79 Earth years.
Huh.
60,189 days.
Well, at least we've got Triton in here. This is good.
All right. Well, what's next?
I want to answer one of the questions. I want to continue answering Laura's question. I have something I want to screen share here. So let me find my
let me stop
Zoom controls here, and I'm going to share my screen. And here we go. Okay. Can you guys see this star map?
Oh, yes.
Okay. So we're looking at the constellation Capricornus here. And Capricornus is kind of to the southwest. And there's Jupiter, right? And there's Saturn. It happens to be that Pluto is right here, almost the same distance from our perspective as Saturn is from Jupiter. Pluto is from Saturn. We're not going to look at Pluto. Pluto it's indistinguishable from a tiny star, right? Now Neptune, which we were just looking at, is over here in Aquarius. So it's a little bit off to the left, more than Jupiter is to the left of Saturn. So you can see here's Jupiter again, and there's Neptune. So anyway, that's all I wanted to show. All right. I wanted to show something else. Give me a sec here.
Mm-hmm.
Sorry. So today is 10/2, and here's the photo. So Gerald had mentioned that we have a new spacecraft from the ESA that has made it to Mercury. And it started sending back some photos just yesterday, today. And I picked out one that I thought was better than the others. And here we go. And it's a little bit of a selfie.
Oh, wow.
And you could see the planet Mercury here and some of the spacecraft structure on the right. And I'm not entirely sure what this is here. Part of the spacecraft.
Part of the spacecraft. That looks like a thruster cone.
It does look like a thruster cone, but I wasn't entirely certain that was the case. So this is not a high resolution image. This is a low resolution image. The interesting thing about this spacecraft is they've sent it to Mercury, but it's right now in this very elongated orbit. And what it's going to do over the next few years is stabilize its orbit. So it's closer to Mercury in orbiting at a much slower speed. And they will then be using the high resolution imager on the spacecraft and also start doing other types of science with the spacecraft. So it's really, just kind of a flyby right now, but it will be coming back and orbiting closer and closer. Yeah, 6 times. Closer and closer to the planet each time. Yeah. So anyway, I just wanted to show that. If I could figure out how to get out of here. I can't.
Okay. You've done it now.
I've done it now. Here we go. Oh, here we go. Stop share. I found the button. All right.
All right. So where to next? M15?
Well, no. I was thinking. Any chance we can see the helix still?
I don't know. I give it a shot here. Let me see what our computer says.
Oh, actually, the helix is pretty close to Jupiter. It's
in the same part of the sky you guys are in right now, and this is the time of year to look at it. So now I hear the music from the party.
No. Hey, listen, I not only hear it, I feel the music for the party. Yeah, it is. Well,
you probably would see the planets vibrating from the music of the party right now.
Okay, I'm gonna go ahead and slew.
All right, let's bring this up to live view.
Okay, you're not going to see it in live view. You're going to have to do probably at least a 20-second exposure.
Yeah.
All right, we'll do it 10 seconds. Just see if we're in the ballpark. Since I see a star. That may be it.
While you're doing that, Brandon asked if we are going to do some kind of a launch party for the James Webb Space Telescope launch, and we are definitely talking about doing that. Stay tuned. The launch won't be until December 18th, so we got a little time yet, but we are definitely talking about doing a launch party for the launch of the James Webb Space Telescope.
I'm not sure you're in the field here.
I don't think so. And
okay. Let me.
We better calibrate here.
Let me go back to Jupiter, and we'll slew there.
All right. I want to go back at the live view, Rick, real quick.
Okay.
We get it centered and synced. And put up the bullseye.
Yeah, I don't think you're in live view, are you?
Yeah.
Yeah. You want me to move it, Gerald?
Oh, okay, never mind.
You want me to move it, or
no?
you want
No, I will move it.
Okay.
Step away from the paddle.
I won. It's my turn.
Oh man.
I don't know why this is happening. Maybe
I don't know
should,
either.
I am turning
it's
the paddle
instant.
over to you because it's
It
Okay.
is.
Okay, Rick, you
All
go
right.
ahead and move it since you're you've
It's
got
like
the
instant.
paddle most closely synced to the camera here. All right, there we go.
I don't know why it wasn't delaying, but now it's back to showing
Okay.
quite a delay.
Sync away.
All right.
And also be sure you're selecting the Helix Nebula, not the Helix Galaxy.
Well, it says the Helix Nebula.
Okay, just very important because you
Okay.
won't see the galaxy.
Okay. Before you go, let's see if we can better the focus on the moons. Yeah, I'd leave it there. Okay, go.
All right, ready?
Yep.
Ready.
Swooing.
Okay.
All right, so you're gonna have to do a timed exposure now.
Okay.
Wait, before you click that, you got to take it out of. Oh, you already did. All right.
Already clicked. Yeah.
I guess that works that way. I usually take it out of frame and focus.
No, we were doing it. You can do it in frame.
You can do it either
focus
way
as well.
yeah.
Yeah. But if you want to save, it doesn't save the.
I just don't see it. That's the thing.
I don't see it either. Yeah.
Oh well.
Longer exposure.
All right, let's go for a longer exposure.
Go for full 30 seconds and see what happens.
Okay. All right, now you've got 30 seconds of airtime to fill.
Yeah.
Yeah. Did you hear the one about the traveling salesman? Oh, no, never mind.
Oh, Gerald,
Yeah.
why don't we tell people about the International Observe the Moon Night?
Okay, we actually got a couple other things to tell them about too. So on October 16th, it will be International Observe the Moon Night. That is a Saturday night. So we will be doing our usual program at 9 o'clock, but our primary focus will be on the moon. And we will be looking at the moon with our telescope, but we will also have some guests that night. The NASA is preparing a new spacecraft to go to the moon. It's a new rover, and it's called Viper. And the plan is to send it to the moon's south pole and put it inside of a crater where they think they may find water ice. And so we are going to have a couple people from NASA join us that night to talk about the Viper mission. So you definitely want to join us on the 16th of October, Saturday night, the 16th of October, starting at 9 o'clock. So how you doing there? It looks
No,
like
that did not work. So
No.
we're trying a different method here, it looks like.
Yeah, we'll try to go to.
But you got to get your ISO up.
Okay, well, while you're doing that, I have something else to announce. There may be, for those of you living in Southern California, Arizona, Mexico, Central America, and South America, I'm sure we have a large audience in those areas, right? You may be able to experience a meteor shower on the night of October 6th, right around about 8 o'clock, 8:30, right around there, Pacific time. A comet called 15P Finley is going to, or has produced a stream of particles, and calculations show that the Earth will pass through that stream of particles on the night of October 6th. That's our time here in the Pacific coast. And it's not 100% sure, but if it happens, the meteors will appear to radiate out of the constellation Ara, A-R-A, which is a southern hemisphere constellation. For those of us here in the Bay Area, Ara is right on the southern horizon, so it's pretty low. We might see a few of the meteors, but if you're farther south, like Southern California, Mexico, Central America, and so on, Ara is much higher up in the sky, and you have a much better chance of seeing it. So again, that's the night of the 6th of October, and the timing is around 8 o'clock p.m. Pacific time. So, Mexico, I think most of Mexico is somewhere on Central time. So it'd be an hour later or 2 hours later, I guess it is. But that's when you want to look for it. And there are predictions that there could be in excess of 100 meteors per hour during this meteor storm. So something to look forward to. What happened is this comet, which orbits the sun every 6.5 years, it had an outburst. That outburst was actually back in 2014. When a comet has an outburst, usually what happens is some piece of it breaks off and there's a sudden release of ice and gases and rocky particles and things like that. And all that material goes into orbit and it trails behind the comet and eventually gets strung out. And a group of astronomers has been calculating the orbit of those particles, and they're fairly well convinced that the Earth is going to pass through that stream of particles on the night of the October 6th. So something to look forward to. Okay, guys.
Well, I think we're going to move on, and I'll tell you what happened here. No. What happened here is we're just not used to a telescope with this image scale, and really we're looking down the throat of the Helix Nebula right now.
Okay.
And that star in the absolute center, that dim star below the bright one, is the central star.
Okay, and I actually can see some of the fringe up on the left there.
Yes, we just brought that out. So this is a terrible object for Nellie, but it's quite remarkable that we can't fit the whole thing into our field of view.
Unlike the ring.
Unlike the ring. So we're going to move on.
I
think you had the right idea, which is
M15, huh? M15. Okay. All right. Well, let's see. We know they're pointing in the right direction.
We are. It's dead center on the central star of the helix.
So I am going to slew up to ENIF. If you'll go into live mode, we'll get centered on ENIF, and then we'll move to M15. I hope everybody can hear us. We're kind of shouting because there is a lot of noise behind us. All right, so.
You want me to center the right
you better
star?
do it. I don't know what the deal is here. Now, see, it's responding immediately now. It's weird.
Oh, okay.
Okay, all right.
All right, you can sync on that.
All right, so we'll sync on that, and then we'll move to M15, and you're going to have to do like a 20-second exposure.
Okay.
Let's zoom in here a little bit because there we go. Okay, we're there. I actually can see a little bit of it.
You can see it, yes.
Yeah,
okay.
there it is. Yeah.
It's in live view, but let's get a better view by taking a timed exposure here.
We'll do a 10-second exposure.
Oh,
yeah,
sure.
I just moved the telescope, so we're going to have a view.
Yeah, see, remember we were going to try to coordinate this, remember?
Oh, yeah, I know.
Hey, once again, everybody, both of my hands.
Yeah,
there we go.
Look at my head, see? All right. Okay.
All right. That's actually a pretty good image.
Yep.
Okay, so this is the Globular Star Cluster, M15. M15 is 33,000, a little over 33,000 light years away. It's what we call a globular cluster because it looks like a ball of stars out in space. M15 is one of about 150 globular star clusters that orbit around our galaxy. They orbit in a region called the halo of the galaxy. The halo, if you imagine what our galaxy looks like, it's like a flat disk with a central bulge. The spiral arms of the galaxy are within the disk, but around all of that is a more or less spherical, very hazy region we call the halo. And the halo has a lot of old stars in it, including all these globular star clusters. Globular star clusters are composed of old stars, more than 10 billion year old stars. And they are very close together. The stars in the cluster orbit around the center of the cluster, and the cluster orbits around the galaxy. The orbits of these stars are highly elongated orbits, so they're not circles. They're like ovals that go in and out, what we call ellipses that go in and out. They get in close to the center, and then they swing way out. Then they come around and they come back in. When they're close to the center, the stars are moving very rapidly. When they're far away from the center, they are much slower. This particular globular star cluster is called a core collapse globular star cluster because the stars have congregated so much near the center that you see, I mean, you can see it in this image here. It's very dense at the center of the globular cluster. And when we measure the mass of the cluster and the distribution of the mass, it turns out there is a lot of mass in a very, very small region of M15, of the globular star cluster. So much so that the best explanation for all that mass being so close to the center is that there is an intermediate mass black hole at the center of the cluster. So we are pretty sure that there's that black hole at the center of this cluster. There's actually several globular clusters where we think there are black holes at the center. So you don't want to live on a planet orbiting one of these stars in this cluster. If you did, you very likely would not have a nighttime because there would be so many other stars so close to you that they would just light up your night sky. And so you might have a not fully daylight bright sky, but you would never have a truly dark sky. It would be like having, 50 or 60 full moons in your night sky. So this is the globular star cluster M15. All right.
Okay.
Do we have time for one more?
Sure.
Well, Bob Schock has requested the Saturn Nebula.
All right, let me sync on this real fast.
And that one's got a much smaller size than the Helix, so we may actually be able to see it.
Okay.
I have to admit, I've never had the experience of something other than the Andromeda Galaxy being so big that we couldn't get the whole thing into the frame. Okay, let's see. Saturn Nebula, right?
Yep.
Oh, that's that's only about a half an arc minute in apparent size.
Yep.
All right.
It's a much more sane
What did I do?
object to go after. Yeah, Bob was mentioning that he could hear the party music.
Is that right? Yeah.
Yeah.
I've got my headphones on, my noise canceling
So
headphones.
we're probably violating some internet.
You're gonna get a note from Facebook here.
Again, we're illegally rebroadcasting somebody's copyrighted music here.
All right. Okay, I'm gonna slew.
Yep.
Slewing. All right.
All right, here we go. We are there.
All right, let me snap. There it is. Okay.
All right.
They
A
go a little
planetary
brighter,
nebula.
sure.
A planetary nebula.
Let's try a 10-second exposure. That was in live view.
Yeah, it's going to be fine probably in 10 seconds.
Yeah.
You can see the central
And you
star
can
even.
see
in
the
live view.
central star. Yeah, absolutely.
Very sensitive.
Yeah,
Yeah.
it's too much. Let's back that off a little.
It's kind of an
There
unusual.
we go. That's good.
There we go. That's it.
That's very good.
Now you notice you can just barely see a couple of little faint appendages extending out from either side. These are actually jets that were blown off of the star as it was when it was still in its red giant phase. So to the left and to the right, slightly at an angle, you can just barely make out the jets. And then you can see a lot of what looks like shock waves within the nebula. This is all the result of the star. Before it became a white dwarf, it was a red giant, expelled gas out into space. And then the star collapsed, became a white dwarf. White dwarf is generating a lot of ultraviolet radiation, which is ionizing the gas and causing it to glow. But in this particular case, this star also blew a lot of gas off the poles of the star, producing what looks like jets. And so you can just barely make them out on either side of the blue halo there. And this distance is not well known. We think it's around 3,900 light years away, but there's a lot of debate about that. So roughly 3,000 to 4,000 light years away.
So it's pretty close.
Yeah.
In the scheme of things.
And once again, you're seeing what will happen to our sun in about 5 or 6 billion years. This is how most stars with less than 8 solar masses of mass, this is how they die. They eventually end up as planetary nebula with a white dwarf at the center. All right.
Well, that was excellent. All right.
Okay. Well, why don't we see if anybody has any questions they want to fire away at us while we can. Speak loudly because there's a lot.
Yeah, right.
Up here.
I will yell the questions out.
Yeah.
All right. I don't see any yet. Anybody have any questions about tonight?
On YouTube.
Yeah.
Now, Darlene, or Dolores, I think it is, asks, is it going nova? No, that's not what's happening here. A nova is a different animal completely. This is the way most stars die. The star, as it gets old, it swells up, becomes a red giant, then it begins to lose its outer layers of gas over tens or hundreds of thousands of years. It just sheds gas, slowly exposing the inner part of the star. Eventually, the fusion process at the center of the star stops. Whatever's left of the star collapses into a white dwarf. The white dwarf is surrounded by all that gas that was blown off when it was a red giant. And you have what we call a planetary nebula. So this is not a nova. Nova is a different animal. Nova involves a white dwarf, but this isn't it. All right.
Yeah, that's a good clarification.
Any other questions?
Somebody was asking about what is a good moon atlas, and I was suggesting the one by Rukl. That's Rukl. And his name is Antonin Rukl, and it's called the Astronomy Atlas of the Moon. For a while, it was reprinted by Sky and Telescope, and it was a reasonable price, but it looks like they stopped printing it again, and now the price has gone through the ceiling once again. So I'm sorry about that, because when it was being reprinted, it was, you know, $25 or $30 or maybe $40, and now it's back up to several $100s because they're hard to get. So,
well, I have another recommendation.
Go for it.
All right, it's called the 21st Century Atlas of the Moon. It's the author is Charles Wood, Wood, and it is readily available on Amazon. I'm looking at one right here for $27. Very good atlas. Charles Wood is one of the world's leading experts on lunar geography. And so it's got lots of cool images. It's got a detailed map. And it's divided up into sections. So he takes the map of the moon and he divides it into sections. And then he's got a separate chapter on each of those sections with a lot of detail about what you're seeing in there. So again, it's called the 21st Century Atlas of the Moon, written by Dr. Charles A. Wood. And bonus points, Dr. Wood was my advisor when I got my master's degree.
There you go.
and no, I don't get a cut.
Yeah, I was about to say, is he sending you commissions? Or,
Yeah, you should get a cut on that, because after you promoted it last time, one of my friends here bought a copy, and of course I had to buy a copy. So
right.
Dr. Wood is doing well.
We're trying to get paid per creator here instead of.
Yeah. And if you happen to have a subscription to Sky and Telescope magazine, you may recognize Dr. Wood because he regularly writes a what do you call it, article in Sky and Telescope almost every month about the moon and about lunar geography. So if you pull out your latest edition of Sky and Telescope, you're likely to find an article in there by Charles Wood. And you can say, oh yeah, he was Gerald McKagan's advisor when he got his master's degree. So very interesting guy. All right.
All right.
Well,
I think we have to call it quits.
We have to call it quits so we can go outside and dance.
We have to dance. Yeah.
That's right. All right, everyone. Thanks for putting up with us and your reverence. I hope you had a good time, and we will see you next week. Once again, I want to remind everyone that we depend on your support, so please make a donation. You can visit our website at www.chabotspace.org, and you can learn how to become a member of Chabot or how to make a donation. So thanks again for your support, and we will see you next week.
Dancing.
Dancing.
I think that'll be about it.
All right.